Hello friends, welcome to the chemistry plan. Now let's discuss about the MH set 2019 question paper. That is the question from the inorganic chemistry. The first question is the total number of lone pair for the ion I3 minus is. Now the I3 minus having the trigonal bipyramidal geometry with central atom is iodine, having the 3 lone pairs and 2 bond pairs. So the total number of lone pair for the ion I3 minus is 3. The question number 2, that is the hybridization for the complex ion ApF6 minus 3 and ApCN6 minus 3 is. Now in both the complexes the iron present in plus 3 oxidation state. Okay, but in case of the ApF6 minus 3 the fluorine is the weak field ligand, while in ApCN6 minus 3 is cyanide is the strong field ligand. So in ApF6 minus 3 for the hybridization the Ap used central atom used the inner d orbital. Okay, not a inner d orbital, that is outer d orbital for the ApF6 minus 3 complex, and in case of the ApCN6 minus 3 outer inner d orbital because of the pairing of electrons. So the hybridization of this is sp3d2 for ApF6 minus 3 and d2sp3 for ApCN6 minus 3. So the correct option is D for question number 2. Now let's move towards the question number 3. Which of the following diatomic molecule is paramagnetic? Now this question based on the molecular orbital theory from the chemical bonding. Now let's check first molecule, that is a B2 molecule. The B2 molecule having the total 10 electrons. Okay, each boron having the 5 electrons, so total 10 electrons. So that is sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. That is all this having the 8 electrons. Then pi 2 px, pi 2 py, each having the single electrons. So there is a 2 unpaired electron present in the B2 molecule. Okay, so B2 molecule is an paramagnetic. Okay, so option number A is correct option. Now question number 4, that is the size of the d orbital for silicon, phosphorus, sulfur and chlorine follow the order. Now you know that from left to right, that is the along the period the electronegativity decreases from silicon to chlorine, that is sorry, not decreases, electronegativity increases from silicon to chlorine. Okay, chlorine is most electronegativity negative than the sulfur, phosphorus and silicon. So the order of size is silicon having the greater size than phosphorus, then sulfur, then chlorine. So option A is correct option because of the electronegativity. Now question number 5, the molecule P4 and CH4 exhibit the same. Option A color, option B geometry, option C boiling point, option D physical state at 300 Kelvin. Okay, now the geometry of the P4 and CH4 is same, that is a tetradic geometry. So option B is correct option for the question number 5. Then question number 6, the bond order for O2 and hypothetical molecule N2 minus and O2 positive will follow the trend. Okay, now the O2 having the 2 bond order, then N2 minus, that is 15 electron, that means the bond order is 2.5, and for the O2 positive also having the 15 electrons, so bond order is 2.5. all this explained in the video of this channel, that is how to calculate bond order. Okay, so you can watch this video from the playlist. So out of this 4 options, no one option is the correct. you're looking towards the option number C, but in this case N2 minus having equal bond order to O2 positive. It is correct. Half part is correct, but it is less than O2. Okay, so any one option is not correct. Now question number 7. According to CFT, nickel plus 2 can have 2 unpaired electron in. Okay, you have to just arrange the electrons of nickel plus 2. Nickel plus 2 having the d8 system, that is a 8 electron present in the d orbital. Okay, so let's arrange these 8 electrons in octal geometry. You know that octal geometry having the T2g orbital in lower energy and EG orbital in the higher energy. So 1 2 field electrons, that is 1 2 3, then in EG 4 5 6 7 8, that is 2 1p electron present in the octal geometry, and also fill the electrons in tetra geometry, that is E set of orbital having the lower energy and T2 set of orbital having the higher energy. So again 2 unp electron present in tetra geometry. So option number C is correct, that is both octahedral and tetra geometry having the 2 unpaired electrons. Okay, then question number 8. Which of the following complexes will not exhibit ideal octahedral geometry? This question based on the John Taylor distortion. Okay, indirectly this question depend on the John Taylor distortion. Now for John Taylor distortion, if the T2g orbital is unsymmetrically filled or EG orbital is unsymmetrically filled, okay, or both the orbital are having the unsymmetrical geometry, unsymmetrical field, then John Taylor happen. Now let's check first, that is titanium H26 plus 3. Now in this complex the titanium present in the plus 3 oxygen state, so number of d electron present in the titanium is only 1 electron. Okay, and the geometry of this complex is, that is titanium H26 plus 3 octal geometry, so this 1 electron present in the T2g orbital. So the T2g set of orbital, it is an unsymmetrical field. So because of the John Taylor distortion, the titanium H26 plus charge on the complex is plus 3, it is not having ideal octahedral geometry. Okay, so option A is correct option because of the John Taylor distortion. Okay, now the question number 9. Okay, the carbonyl switching frequency for the complex cobalt carbonyl for charge on the complex is -1, then second complex is nickel tetracarbonyl, then third complex is FeCO4 -2. Will follow the trend. Now just remember the one thing is that as the charge on the complex ion, okay, charge on the complex is in all these three complexes the ligand is neutral. Okay, carbonyl is a neutral ligand, so charge on the complex ion means the charge on the central metal atom is which one having the more negative charge, that is a FeCO4 -2. Okay, as the charge negative charge on the central atom increases, the back donation, pi back donation from metal to carbonyl ligand increases. Because of that the carbonyl stretching frequency decreases. Okay, so FeCO4 -2 having the most negative charge on the Fe, so it is the greater back donation. That means lowest carbonyl stretching frequency for the FeCO4 -2, that is option 3, not option 3, that is 3 having the lowest. Then CO4 cobalt tetracarbonyl minus. Okay, then A, and then second, that is nickel tetracarbonyl having the highest carbonyl stretching frequency, then cobalt carbonyl 4 -1, then FeCO4 -2. That is option number D. Option D is correct option. Question number 10. The spin only magnetic moment for the complex mercury in square bracket, that is cobalt is CN4, that is thiocyanate, it is an weak field ligand, okay, and SN having the -1 charge. So the total cobalt present in the plus oxygen state in this complex, the cobalt present in the plus oxygen state, so total number of unpaired electron present in this complex is, that is a T7 case, and in D7 case, in case of the in the D7 case, that is the total number of electron present is field electron in case of the tetrageometry, that is E set having the 1 2 then 3 4 5 6 7, okay, so 3 unpaired electron present in cobalt, okay, which having the +2 oxidation state. So you know that the spin only magnetic moment, formula for the spin only magnetic moment is square root of n into n plus 2 per magnetron, okay, square root of n into n plus 2, n means number of unpaired electrons, so square root of 3 into 3 plus 2, okay, that is a square root of 15. So option B is correct option, okay. Now this is all question for the part 1, okay. Like, share, comment and subscribe to our channel Chemistry R for the more videos. Thank you for watching video.